James Webb Telescope spots the earliest known, quenched, galaxy. What does this mean for our understanding of the universe? The James Webb Space Telescope has made a groundbreaking discovery in space. It has spotted the earliest known galaxy that abruptly stopped forming stars. The galaxy, called GS 9209, quenched its star formation more than 12.5 billion years ago. This was only a little over a billion years after the Big Bang. The discovery sheds light on how galaxies form and evolve throughout cosmic time. The study was reported on January 26 at archive.org, and it reveals that at least some galaxies quenched when the universe was young. The galaxy was first discovered in the early 2000s. In recent years, observations with ground-based telescopes identified it as a possible quenched galaxy based on the wavelengths of light it emits. However, Earth's atmosphere absorbs the infrared wavelengths that could confirm the galaxy's distance and that its star-forming days were behind it. Thus it was impossible to know for sure. To solve this problem, astrophysicist Adam Carnell and colleagues turned to the James Webb Space Telescope, or JWST. The observatory is highly sensitive to infrared light, and it is above the blockade of Earth's atmosphere. JWST has much greater sensitivity than earlier telescopes, which lets it see fainter, more distant galaxies. While the largest telescopes on the ground could maybe see GS 9209 in detail after a month of observing, JWST can pick this stuff up in a few hours. Using JWST observations, Carnell and colleagues found that GS 9209 formed most of its stars during a 200 million year period, starting about 600 million years after the Big Bang. In that cosmically brief moment, it built about 40 billion solar masses worth of stars, which is about the same as the Milky Way has. That quick construction suggests that GS 9209 formed from a massive cloud of gas and dust collapsing and igniting stars all at once. It's pretty clear that the vast majority of the stars that are currently there formed in this big burst, Carnell says. Astronomers used to think that the mode of galaxy formation called monolithic collapse was the way that most galaxies form. But the idea has fallen out of favor, replaced by the notion that large galaxies form from the slow merging of many smaller ones. However, Carnell says, now it looks like, at least for this object, monolithic collapse is what happened. This is probably the clearest proof yet that that kind of galaxy evolution happens. As to what caused the galaxy's star-forming frenzy to suddenly stop, the culprit appears to be an actively feeding black hole. The JWST observations detected extra emission of infrared light associated with a rapidly swirling mass of energized hydrogen, which is a sign of an accreting black hole. The black hole appears to be up to 1 billion times the mass of the Sun. To reach that mass in less than 1 billion years after the birth of the universe, the black hole must have been feeding even faster earlier on in its life, Carnell says. As it gorged, it would have collected a glowing disk of white-hot gas and dust around it. If you have all that radiation spewing out of the black hole, any gas that's nearby is going to be heated up to an incredible extent, which stops it from falling into stars, Carnell says. The discovery is significant for astronomers as it provides them with a new understanding of how galaxies evolved. The JWST has been able to provide more detailed observations than ground-based telescopes, which allowed scientists to confirm the quenched status of the galaxy. This discovery also helps researchers understand how galaxies evolve over time. By studying the earliest known quenched galaxy, scientists can gain insights into the processes that lead to the shutdown of star formation in other galaxies. Understanding how and why galaxies stop forming stars is crucial to understanding the evolution of the universe. In addition to the James Webb Space Telescope, other telescopes are also contributing to our understanding of quenched galaxies. For example, the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile has also observed quenched galaxies, revealing that they contain large amounts of gas and dust. This suggests that these galaxies may be able to reignite their star-forming activity if they were to encounter a triggering event. While the discovery of GS 9209 is exciting, it is just the beginning. Scientists will continue to use telescopes like the James Webb Space Telescope to observe the universe and search for more quenched galaxies. By studying these galaxies, they hope to gain a better understanding of the conditions that lead to quenching and how galaxies evolve over time. In conclusion, the discovery of GS 9209 is a significant milestone in our understanding of the universe. It represents the earliest known quenched galaxy and sheds new light on how galaxies evolve over time. The observations made by the James Webb Space Telescope suggest that the galaxy's star-forming activity was shut down by an actively feeding black hole. This discovery not only helps us understand how galaxies die, but also how they are born. By studying the earliest galaxies in the universe, scientists hope to learn more about the processes that led to the formation of the structures we see today. The James Webb Space Telescope and other telescopes will continue to play a crucial role in expanding our knowledge of the universe and the galaxies that inhabit it.